Good morning, all of you. I am Ram Mohan, presently working as head of the department at Government Polytechnic, Mahabubnagar. Our subject is basic electronics, and the topic is resistors. So, the subtopic in that is property of resistance and the Ohm's law. The objectives. On the completion of this class, you would be able to understand the property of resistance and the Ohm's law. Now, let us come from the unknown to the known. Known to the unknown. Would you name some of the electrical gadgets? Electrical appliances at home: bulb, fan, refrigerator, telephone, computer, etc. And some of them are a computer again. Let us visualize them, how they look like. And this is actually a loudspeaker. It's an electrical gadget. Computer. Then what do they require for working? Would you tell? Yes, it is current or electricity. A layman generally says it is a current, but appropriately that is electricity that will drive all these gadgets, which will give energy for them to work. Then what's a current? The flow of electrons constitute current. What do we understand when somebody says, what do we do when somebody says sun rises in the west? Does the sun never rise in the west? No, it will never. It rises in the east. So we would like to oppose that. Yes, we oppose that. What do we do when somebody tries to steal something from you? We will resist. We will oppose. We will fight to save your wallet or your chain. Is it? Yes, we will oppose or we will resist that action. How do we generally react to a change in a system? We will oppose or resist. Isn't it? System in the sense, suppose you normally board a bus from behind for gents and for females from the front door near the driver. They change it tomorrow. Then how would you do it? How would you react? We don't want it to happen because you got used to getting into the bus from the rear entry, and for the females it is the front side door. That's it. So we oppose or resist it. Then let us look into the property of resistance. The property of the material to oppose the flow of current is known as the resistance. Then what are the units we use for measuring it? The unit of resistance is ohm and is denoted by the symbol like this, ohm. Ohm's law. Let us see what is the statement for Ohm's law. The Ohm's law gives the relationship between the applied potential difference across the conductor and the resulting current passing through it, that is flowing through it. Okay. Statement of Ohm's law is the temperature, when the temperature remains constant, the current passing through a conductor is directly proportional to the applied voltage across the conductor, right? Mathematically, it is expressed like this: voltage is proportional to the current. V is proportional to I. V is the symbol for voltage, I is the symbol for current. Then, how do you equate it? So, V is equal to a constant multiplied by the current. It's a product of that. And that constant here is resistance in our situation. Otherwise, R resistance is equal to voltage divided by the current. That means the resistance is inversely proportional to the current flowing through the conductor and directly proportional to the voltage applied to that conductor, right? Or it can also be expressed as current equal to voltage by resistor, where V denotes the voltage applied to the conductor in volts, which is across that. I is the current passing through the conductor in amperes, whereas amperes is the units for current and volts is the units for voltage. R is the resistance of the conductor expressed in ohms. So the units of measurement of resistance is ohms. Now let us look into the limitations of the Ohm's law. Ohm's law cannot be applied to a non-linear device such as vacuum tubes or gas filled devices and semiconductor devices. Vacuum tubes, of course, they are obsolete now, but still some of them we can see in a cathode ray tube or in a old model CRT type of televisions and in CRO radars nowadays. Well, gas filled devices are obsolete. Semiconductor devices are like transistors, ICs, diodes, etc. Now it cannot be applied to arcing devices. Like we have some arcing devices like SCRs and some other which are used in high power applications. It cannot be applied to those electrolytes in which the gases are liberated on the electrodes. Okay. It cannot be applied to those conductors whose temperature changes due to the flow of current through them. Like suppose you have a water heater, its property is to give you heat. Like when the temperature, like when you apply the voltage, the temperature goes on increasing. So such places you cannot apply this Ohm's law. And in the statement itself says initially when the temperature is kept constant. So we have to maintain the temperature constant, only then the Ohm's law can be applicable. Let us see now what a resistor is, how it looks like. Did you ever see this component? Yes, some of you might have seen it, especially when you open a television or any electronic appliance. You might have seen this. This is a resistor. This what you are seeing is a carbon film resistor. Well, it is resistor's definition. A passive component that offers resistance is known as a resistor. Symbol is this. Resistor is represented by the letter R in all the circuits and it is drawn like this. The circuit symbol of a resistor is this. And sometimes there will be only two zigzag curves. Okay. So a resistor will have two ends or connectors ends. Now the unit of resistance is ohm and is denoted by the symbol ohm. When a voltage is applied across a resistor and I is the current passing through it, then according to the Ohm's law, The resistance R is equal to V by I. So we'll be calculating, if the resistance value is unknown, then you'll be calculating using this expression. R is equal to V by I. So what we'll do, so we'll be measuring the voltage across that element, and you'll measure the current flowing through that resistor. Then we can easily calculate the resistance of the resistor.